Remote interfaces are a key part of Enterprise JavaBeans, or EJB. They enable communication between different parts of an application, even if those parts are running on different servers. Think of it like a phone line. It allows two people to talk even if they are miles apart. Similarly, remote interfaces allow different parts of an application to interact, regardless of their physical location. In enterprise Java development, we often build applications that are distributed. This means that the application is not located in a single place, but is spread across multiple servers. This is necessary for large, complex applications that need to handle a lot of users or data. To make this work, we need a way for the different parts of the application to communicate with each other. That's where remote interfaces come in. Remote interfaces act as a bridge between different parts of the application, allowing them to interact and share data. This is essential for building robust and scalable enterprise applications. Remote interfaces have three key components: contract definition, communication abstraction, and enabling remote invocation. Let's break down each of these components. Contract definition refers to the specific methods that are available through the remote interface. This is like a menu at a restaurant. It tells you what dishes are available to order. Similarly, the contract definition of a remote interface tells the other parts of the application what operations they can perform. Communication abstraction deals with how the different parts of the application actually communicate with each other. This is like the phone line in our earlier analogy. It provides the means for the two parties to connect and exchange information. In the case of remote interfaces, communication abstraction is handled by underlying technologies like RMI, or remote method invocation, or web services. Finally, enabling remote invocation refers to the mechanisms that allow the different parts of the application to call the methods defined in the remote interface. This is like placing an order at the restaurant. You use the menu to choose a dish, and the waiter relays your order to the kitchen. Let's consider a real-world example to illustrate how remote interfaces function. Imagine a banking application where customers can access their accounts and perform transactions online. This application is likely distributed, with different servers handling different functions like account management, transaction processing, and security. To enable these different parts of the application to interact seamlessly, we can use remote interfaces. For instance, the account management server might expose a remote interface with methods for checking account balance, transferring funds, and updating personal information. The transaction processing server can then use this remote interface to perform the necessary operations when a customer initiates a transaction. In this scenario, the remote interface acts as a bridge between the account management and transaction processing servers. It defines the contract for interaction, abstracts away the complexities of communication, and enables the servers to invoke each other's methods remotely. This ensures that the banking application functions smoothly and efficiently, regardless of the physical location of its components. One of the key benefits of remote interfaces is communication abstraction. This means that the different parts of the application don't need to know how the communication is actually happening. They simply interact with the remote interface, and the underlying technology handles the details of sending and receiving data. This simplifies development and makes the application more flexible. Think of it like sending a letter. You don't need to know how the postal service works to send a letter. You simply write the letter, address it, and drop it in a mailbox. The postal service takes care of the rest. Similarly, with remote interfaces, the developers don't need to worry about the low-level details of communication. They can focus on the business logic of the application, while the underlying technology handles the communication aspects. This abstraction is crucial for building complex distributed applications. It allows developers to focus on the core functionality of the application without getting bogged down in the complexities of network communication. This results in cleaner code, faster development cycles, and more maintainable applications. Section 5. Defining contracts in remote interfaces. The contract definition in a remote interface is crucial for ensuring seamless interaction between different parts of the application. It specifies the methods that are available, their parameters, return types, and any exceptions they might throw. This is essentially a blueprint for how the different parts of the application can interact. Imagine you are building a house. You wouldn't start construction without a blueprint, would you? Similarly, you shouldn't build a distributed application without defining clear contracts for how the different parts will interact. The contract definition in a remote interface acts as this blueprint, providing a clear and unambiguous specification for communication. This contract-based approach offers several advantages. It promotes modularity, as different teams can work on different parts of the application independently, as long as they adhere to the defined contracts. It also enhances maintainability, as changes to one part of the application are less likely to break other parts, as long as the contracts remain compatible. Enabling remote invocation is the final piece of the puzzle in remote interfaces. It involves the mechanisms that allow the different parts of the application to actually call the methods defined in the remote interface. This is where the underlying technology comes into play, using protocols like RMI or web services to transmit the method calls and their parameters across the network. Think of it like making a phone call. You dial a number, invoke a method, the phone system transmits your voice over the phone lines, and the person on the other end hears you. Similarly, in remote interfaces, the underlying technology transmits the method calls and their parameters over the network, enabling the remote execution of the requested operations. This seamless remote invocation is what makes distributed applications possible. It allows different parts of the application to interact as if they were located in the same place, even though they might be physically separated. This opens up a world of possibilities for building scalable and flexible enterprise applications. Using remote interfaces in enterprise Java development offers several benefits. Firstly, it promotes modularity by allowing different parts of the application to be developed and deployed independently. This simplifies development, testing, and maintenance. Secondly, it enhances scalability by enabling the application to be distributed across multiple servers, allowing it to handle increased load and data volume. Thirdly, remote interfaces improve fault tolerance by isolating failures. If one part of the application fails, it doesn't necessarily bring down the entire system. Other parts can continue functioning, and the failed component can be restarted or replaced without disrupting the entire application. Finally, remote interfaces facilitate communication between different platforms and technologies. By using standard protocols like RMI or web services, applications built with different technologies can interact seamlessly, expanding the possibilities for integration and collaboration. Remote interfaces play a vital role in enabling distributed communication in enterprise applications. They provide a structured and efficient way for different parts of the application to interact, regardless of their physical location. This is crucial for building large, complex applications that need to handle a lot of users or data. Think of a global e-commerce platform. It needs to handle millions of users from around the world, process transactions, manage inventory, and provide customer support. This is impossible to achieve with a single server. Instead, the application is distributed across multiple servers, each handling a specific part of the workload. Remote interfaces act as the glue that holds these different parts together, allowing them to communicate and coordinate their actions. This distributed approach offers several advantages. It improves performance by spreading the workload across multiple servers. It enhances scalability by allowing the application to grow by adding more servers as needed. And it increases fault tolerance by ensuring that the failure of one server doesn't bring down the entire system. In conclusion, remote interfaces are a powerful tool for building robust, scalable, and flexible enterprise Java applications. They provide a structured and efficient way to enable communication between different parts of the application, regardless of their physical location. By abstracting away the complexities of communication, defining clear contracts for interaction, and enabling seamless remote invocation, remote interfaces empower developers to build sophisticated distributed applications that can meet the demands of modern businesses. From banking operations to global e-commerce platforms, remote interfaces play a vital role in enabling the distributed applications that power our digital world. By understanding the concepts and benefits of remote interfaces, developers can leverage this powerful tool to build the next generation of enterprise applications.